All right, I know this is super weird, but this is the part of Algebra 2, really, that made me decide I really liked math. I thought it was pretty cool how it worked. And so we're going to be multiplying and dividing rational expressions just to make sure you really remember. Rational expressions mean that they are fractions, ratios. Okay, so we're going to be working with fractions. So all of those fraction, adding, subtracting, multiplying, dividing, all of those rules you learned in elementary school and middle school, those are going to come back to bite you and actually just be exciting when we do these. So here we have a simplified example. This is with monomials, and you could do this another way, but I'm going to show you this the way that will lead into rational expressions. So the first thing you're going to do is factor each polynomial, if possible. That's first. Okay. The second thing you're going to do is multiply. And then you're going to simplify. All right, so these are the steps. We're going to factor, multiply, and simplify. So can we factor any of these? No, they're not factorable. They're monomials. So we're going to go to step 2, which is multiply. 6 times 10 is 60. We have x and y. 2x's, 3x's, when we multiply, we add. So we have 5. We have 3 and 4, so 7 for y. Same in the denominator. 2 times 18 is 36. X squared, because there's no more here, and y to the 4th, because we have 2 and 2. So we multiply. Now we'll simplify. What are 60 and 36 both divisible by? The first thing that pops in my head is 6. So let's see if that's enough. Nope, we can do more. So I'm going to divide by 2. That's 5. And that's 3. So I know I'm going to have 5 and 3 like that. I like to do it like this when it's monomials. I write everything on the top, and then if it has a negative exponent, I move it later. When we're dividing, we subtract. So we have 5 minus 2, which is 3, and 7 minus 4, which is also 3. So this is the answer. Of course, you could also write this as 5/3 x cubed y cubed. So that's when it has monomials. Let's look at the first one that has actual polynomials. The first thing you want to do is factor these polynomials one at a time. That's a lot of work, which is why I asked you to get really good at factoring. So I'm going to write this out like this. We're going to factor. So let's look at the first one. 4x squared minus 4x. Is there a GCF? Yes. 4x, and we're left with x minus 1. Let's look at the next one. And if you need help with factoring, you're going to need to go back to the factoring videos or ask me questions, because I'm just going to kind of go through them out loud, but I'm not going to write down everything if I don't need to. So is it a GCF? No. Is it a binomial? No. Is it a trinomial? Yes. Is it perfect square trinomial? No. So we need to factor. What are the factors of -6 that add up to +2 or +1? They are +3 and -2. So we have x plus 3, x minus 2. Now this one. Is there a GCF? Yes, the GCF is 2. So we're going to pull out the 2, and we're left with x squared plus 2x minus 3. Now this is probably still factorable, so we're going to have to write this again. What is the GCF for x? We're left with x plus 2. All right, let's keep going. This one is actually still factorable, so everything else remains the same. What are the factors of -3 that add up to +2? X plus 3, x minus 1. X plus 3, x minus 2. And we're just rewriting this side. All right, so now we're going to multiply everything. So we have 4, x minus 1, x plus 3, x minus 2, because remember when you multiply the numerators and you multiply the denominators. So as far as the denominator goes, we have 2 times 4x, that's 8x, x plus 3, x minus 1, x plus 2. So we're done with multiplying. Now we simplify. So we're going to go through and we're going to cross off anything that there is the same on the top and the bottom. So we have x minus 1 and x minus 1, x plus 3 and x plus 3. And actually we can simplify this too. So that would be 1 over 2. So the final answer is x minus 2 over 2 times x plus 2. Weird, right? It's a lot of work and it's a lot of steps. If you may have a lot of scratch work going on if you're still working on factoring on paper. Sometimes I do that too. And I'm going to show you in the next one another way that I kind of write it sometimes. I'm trying to decide if I want to. That I think might work faster. So I'm going to show you just another method that might help. If it doesn't help you, then just write it this way. Okay? Sometimes when I factor, I like to put the factored part right above, like this. So I would say, can I take anything out? Yes, I can take out 5v. So that leaves me 2 minus v. Over here, the factors of negative 9 that add up to negative 8 would be x minus 9, x plus 1. And again, if that part is hard for you, please let me know and I'll help you with factoring more. This one is already simplified or factored. And this one, what are the factors of 18 that add up to negative 11? 18 is 1 and 18, 2 and 9. That would work, 2 and 9, because I could do x minus 2 and x minus 9. Those two negatives add up to negative 11 and multiply to positive 18. So I'm all factored. So I'm going to multiply now. 5v, 2 minus v, x minus 9, x plus 1. That's just multiplying the numerators over x minus, why am I putting x? These are all supposed to be v's. V minus 2, v minus 9, and 15v. So let's go through and cross out anything that matches exactly. We have v minus 9s. This v right here, we can simplify to 1/3, like that. And so what we're left with right now is 2 minus v over 3v minus 2. All right. This is one of those situations where you're like, but these are so close. If only I could switch the order. And you can. You can switch the order in either one of them, really, by factoring out a negative. So I'm going to do it in the top. I'm going to pull out a negative 1 and change it to v minus 2. The bottom's going to stay the same. And now we have that good match. So the actual answer is negative 1/3. Isn't that kind of cool? I think it's kind of cool. All right, I'm going to stop this video and then make another one for dividing just so it's not super long. But it's almost the same process. So come back for dividing.